Hello everyone, it's Miss Barber for lesson 5.5 and 5.6 in geometry. We're going to talk about the triangle inequality theorem and the Hinge theorem. So we're going to be comparing sides with angles of one triangle and then within two triangles. So to start, comparing sides to angles. The largest angle will always be opposite the longest side, and vice versa. So my largest angle here is at the top, so the opposite is all the way across from the triangle, and that will give you the longest side. Vice versa, the longest side will be opposite the largest angle. The smallest angle will also be opposite the shortest side and vice versa. So here's the smallest angle. Go across the triangle, that will give you the shortest side. So you should be able to, if you know what the largest or the smallest angle is, order your sides and angles from least to greatest. So here in example 1, they told me angle C is 71 and angle B is 42. They didn't tell me what angle A is, but I can find it. Remember, all three angles have to add to 180, so angle A would be 67 degrees. So 67 plus 71 plus 42 equals 180. To find the shortest side, I need to look for the smallest angle. My smallest angle is angle B, so if I go all the way across the triangle to AC, that will be my shortest side. So AC will be my shortest side. My longest side will be across from my biggest angle. So my biggest angle is 71, so go opposite across the triangle, and AB will be your longest side. We can go the opposite way, where instead of me giving you angles and you telling me about the sides, I can give you the sides and you give me the angles. So the smallest angle, again, is going to be opposite the smallest side. The smallest side is AB, so all the way across from it would be angle C. Notice the angle and the side opposite don't touch, and that's always the case. So angle C would be my smallest. My largest angle will be opposite the largest side. So here's the largest side is 18 AC, so the largest angle would be B, across the triangle from it, not touching it at all. Example 3, it wants us to write the measurements in order from least to greatest. So we're going to start with the least up here and then go to the greatest here. They gave me the angles, so now I'm going to compare the sides. The smallest side will be across from the smallest angle. The smallest angle is C, 37, so AB will be my smallest side. So that will be the least side, AB. Continuing with this pattern, my next smallest angle is B, so the side opposite B would be AC. The greatest side will be opposite the greatest angle. It's the only one left at this point. 88 is opposite BC, so BC will be my greatest side. I can go the opposite way, give me the sides, and I'll write the angles. So again, I'm going to start with the least and go to the greatest. The smallest angle will be opposite the smallest side. Smallest side is DF. Well, the only angle that's not touching D or F is E. So E is opposite. So angle E is the least. Continuing on with this, 12 is my next smallest side. Angle D is the one not touching 12, so that will be my next. And then my biggest side is 21. So angle F is opposite. That's the last one. So that's just comparing angles with sides within a triangle. What the triangle inequality theorem says is the sum of any two lengths of two sides of a triangle has to be greater than the third. So for any triangle, usually we let C be the biggest side. So if C is the biggest side, then we would say A plus B, my two smaller, would have to be greater than C. So your two smaller, when you add them together, would have to be bigger than your largest side. So to see if a triangle is possible, you add the two smaller sides together and compare it to the largest. If it works, then it is a triangle. If it's not, then it's not a triangle. So let's look here. Determine if these three sides can make a triangle. My two smaller sides are 6 and 6. So I want to check to see if 6 plus 6 is going to be greater than 12. Well, 6 plus 6 is 12, and 12 is not greater than 12. That's not true. They're the same. So this would not be a triangle. And again, you just keep doing that for each of these problems. For number 2, 14 and 26 are my two smallest sides, so I'm going to add 14 and 26 together and see if it's bigger than the third side of 39. 14 plus 26 is 40, and 40 is bigger than 39, that's true, so this is a triangle. In lesson 5.7, we'll actually be able to say whether it's a acute, right, or obtuse triangle using the converse of the Pythagorean theorem. So that's coming a little later. Number 3, again, I have to choose the two smallest sides. The two smallest sides are 4 and 2. They're out of order this time, but that's okay. So I'm going to see if 4 plus 2 is greater than 8. Well, 6 is not going to be greater than 8, so this is not a triangle. You can pause the video and try the next 3 on your own. If you do, 4 and 6 should give you answers of a triangle, and number 5 does not. So again, pause the video and try that. For the next part, find the lengths of the two sides of a triangle. One is 5 feet and the other is 8 feet. What is the range? So when you see the word range, what it wants you to do is write your answer like this. I'm using X, you could use S for sides. So what is the smallest it can be? That's going to go on the left, so the small is going to go on the left. And what's the largest it can be on the right for the third side? Well, this is how you could set it up. So to set it up, option 1. So your first option is that your side of 8 is the largest. So if 8 is your largest, what that means is 5, the side we know, plus the side we don't know. I'll call it X. You could use S, but 5 and S's look the same. So, sorry, I didn't mean to be equals. It should be greater than. That 5 plus my other side has to be bigger than my largest, which is 8. If I subtract 5 from both sides, that means X has to be bigger than 3. Meaning 3 is the smallest end it can be, but it can't include 3. So anything bigger than 3 works, so 3.1 would work, but not 3. But 3's on the small end. My second option, option 2, is that 8 is not the largest. If 8 is not the largest, then that would mean X, my third side that I don't know, is the largest. 5 is never going to be the largest because 5 is already smaller than 8. So then in this case, I would say 5 plus 8, my two smaller sides have to be greater than my largest, which is X. Well, 5 plus 8 is 13. So X has to be less than 13. Meaning 13 is on the top range of my numbers. It can't be 13, it has to be less. 12.9 works, but 13 and above doesn't. So this is actually your answer. You might think, well, that seems a little complicated, and if you think about it, it shouldn't be too bad. But how did we get 3? We got it from subtracting my two numbers. How did we get 13? We got it from adding. So in general, you could use this as a little shortcut, where X on the bottom, you're going to subtract your numbers. Make sure you subtract them so they're positive. And then X on the top, you're going to add the sides that they gave you. So on the bottom, you subtract the sides that they told you. and on the top you add them. That's a shortcut that you can use for letter B. So if you think you got it, you could pause the video and try letter B. If not, you can continue to watch. So for letter B, again, we're going to set it up as a range. We're talking about the range of possible sides. I'll use S this time. The two sides they gave me are 10 and 60. To find the bottom part of my range, we said here we have to subtract. So I'm going to do 60 minus 10, subtract so that it's positive. To find the top edge of your range, you have to add them. So I'm going to do 60 plus 10. 60 minus 10 is 50. 60 plus 10 is 70. So that would be the range of possible side lengths, meaning different numbers that are in this range would work. So 51 could be a side length. 68 could be a side length. 61.5 could be a side length. 69.9 could be a side length. But 49 would not be able to be a side length. It's less than 50. Just like 50 wouldn't be able to be a side. 70 is too big. It can't be. As long as it's greater than 50 and less than 70, though, it would be a possible third side length that would still form a triangle. Last part is the Hinge theorem. And the Hinge theorem is really a long thing. But what it says is, if you have two triangles where you have two sets of congruent sides. So you'll see in my picture, I have Vx is equal to RT. I also have VW is equal to RS. So I have two triangles with two sets of congruent sides. You can either compare the third side or the included angle based off of either the angle or the side you were given. So here in my left example, they told me angle V is 88, so the angle between the two sides that I know is 88, and the comparative angle in my other triangle is 35. Well, because 88 is bigger than 35, I would expect WX, the side opposite it, to be bigger than ST, the side opposite 35. And the same thing holds true if I would do it for angles. Again, we still need my two sets of congruent sides. So CB here is congruent to FE. AC is congruent to DF. Those are my two sets of congruent sides. If I wanted to compare angles now, well, AB is 12 and DE is 9. So the angle opposite 12C, I would expect to be bigger than angle F, which is opposite 9, because 12 is bigger than 9. That's called the Hinge theorem. And the reason it's called the Hinge theorem is if you think of the angle, like angle V here, as the hinge of a door, right? The wider the angle is, the bigger the door swings out, the bigger the space between the door and the wall, which would be the side opposite the angle. So that's why it's called the Hinge theorem. So in example 6, letter A, again, just double check that you have your two sets of congruent sides. I do. JK is congruent to RS, KL is congruent to RT. They gave me angles and they want me to compare the sides. Well, angle K is 59, angle R is 60. So the side opposite 59, JL, I would expect to be less than the side opposite 60, which is SR. So I'm going to draw my inequality toward S opening to ST, because ST is the bigger side. And remember, if you think of it as an alligator, it's eating the bigger thing. So ST is going to be bigger than JL. In my second example, they only marked one set of congruent sides, so they said DE is congruent to EF, but remember EG is shared between them, so that would be congruent. They want us to compare these angles in here, DEG and FEG, so those two angles. Well, let's look at the side opposite. We have 15 and 14. 15 is bigger than 14, so DEG should be bigger than FEG. So that's how you compare sides and angles, either within a triangle or between two triangles. Especially the triangle inequality theorem, we're going to come back to when we do the converse of the Pythagorean theorem. And remember, all of this goes with triangles, so we can add this to our previous lessons in our basically bucket of all the